Physical topology. The term physical topology refers to way in which a network is laid out physically. Two or more devices connect to link. Two or more links form a topology. The topology of a network is a geometric representation of relationship of all links and linking devices, usually called nodes, to one another. There are four basic topologies such as mesh, star, bus, and ring. So basically, node are linking devices. The topology of a network is geometrical representation of relationship of all links and linking devices. So relationship between all links and linking devices are called nodes. So categories of topologies are mesh, star, bus, ring. So these are topologies uh, of nodes, that is mesh, star, bus, ring, etc. Mesh. In a mesh topology, every device has a dedicated point-to-point link to every other device. That means every device is connected to other device. The term dedicated means that link carries traffic only between two devices it connects. That means each dedicated device carries traffic only between two devices which it is connecting, that is stations. To find number of physical links in a fully connected network with n nodes, we first consider that each node must to be connected to every other node. So each node is connected to every other node. Node 1 must be connected to n minus 1 nodes, and node 2 must be connected to n minus 1 nodes, and finally node n must be connected to n minus 1 nodes. We needs n into n minus 1 physical links. However, if each physical link allows communication in both directions, duplex mode, we can divide the number of links by 2. In other words, we can say that in mesh topology we need n into n minus 1 divided by 2 duplex mode links. To accommodate that many links, every device on the network must have n minus 1 IO ports. Now in this figure, that is a fully connected mesh topology, all the ports must be connected to other n minus 1 stations. A mesh offers several advantages over other network topologies. So mesh topology is advantageous as compared to other. First, the use of dedicated links guarantee that each connection can carry its own data load. So each connection can carry its own data load, thus eliminating the traffic problems that can occur when links must be shared to multiple devices. That means when links are shared to multiple devices, traffic problems can occur. Second, a mesh topology is a robust. So that means it is robust. If one link becomes unusable, it does not incapacitate the entire system. So if one link is unusable, that means it becomes useless. It does not incapacitate, that means it does not fail other entire system. So if one link become unusable, so entire system is not failed. Third, there is advantages of privacy and security. So privacy and security, it has advantage. Finally, a point to point link makes fault identification and fault isolation easy. So it is easy to identify faults due to point links. Traffic can be routed to avoid links with suspected problems. The main disadvantages of mesh are related to amount of cabling and the number of IO ports required. First, because every device must be connected to every other device, installation and reconnection are difficult. Second, the sheer bulk of the wiring can be greater and available space, that is walls, ceilings or floors, can accommodate. Finally, the hardware required to connect each IO ports can be prohibitively expensive. That means this is disadvantage, that this kind of topologies are expensive, that is mesh topology. So there are several advantages also and disadvantages also in a fully connected mesh topology.